Okay, now let's do the same thing for a long-run firm, okay? The main difference here is that in the long run, labor and capital are choices, okay? So we're not going to be able to plug in this K bar anymore. We still have profit is equal to P times Q, sales minus costs. And we still have that the production function looks something like this. But now we're not, that's all we have. All right, we plug this in and we get this equation. Now how are we going to solve this? We're actually going to solve it the exact same way, except now we're going to have to solve a system of equations, okay? So what do I mean by saying we're going to solve it the exact same way? We're going to take the partial derivative with respect to our choices, and those are going to tell us how profit changes when we change the things we have control over. In this case, we have control over labor and capital. The firm is choosing how much to buy of each. So we've already done the partial derivative with respect to labor. It's still the same. We take P times the partial derivative of F with respect to L. And we still have W over here, and the derivative over here is still 0. And by the exact same arguments as before, we want that to equal 0. If it didn't equal 0, we could hire more labor and either hire more or less labor. One or the other is going to give us more profit. So only when it's equal to 0 are we at the maximum. But now we've got another choice too. We can also take the derivative, and we need to take the derivative with respect to capital. Okay? So that looks very similar. We have price, and we have to take the derivative of this function. We don't know what the function is, so this is the best we can do. The derivative of this term here, the W times L, with respect to capital is 0, but this is R, and we get this. Okay? And we would also need to, we could in theory have to take the next derivatives to make sure that this first order condition equal to 0 thing gives us the max and not the min. But if we're assuming diminishing marginal products of labor and capital, we know that that's going to be satisfied. These are now our two first order conditions, so I have a little s. All right? And notice that we still have the logic that price times the marginal product of labor is equal to the wage rate. But now we also have that the price times the marginal product of capital is equal to R, because this here, the derivative of the production function with respect to capital is the marginal product of capital. Okay? So this is telling us that we want now to satisfy both those conditions. We want to hire capital until the cost of one more unit of renting one more machine, one more robot, exactly equals the increase in revenue that extra robot is going to get us. The challenge is that we can't do these independently. We have to do them together. Because as we saw, the amount of capital you have affects the marginal product of labor. And so the answer to this is going to affect this. Okay? One more interesting thing. Let's take these two equations and combine them, okay? So I have price times the marginal product of labor here, and I'm going to divide it by the marginal product of capital over here, times the price. I know that the price times the marginal product of labor is equal to the wage rate, so I could divide both sides by the same thing, but price times the marginal product of capital is also equal to R, so this is doing that trick where I divide one equation by the other. What do I get? Well, these cross out. These are gone. And I get the marginal product of labor divided by the marginal product of capital is equal to W over R. Okay? Let's stick a negative sign in front of each of these. And now this term over here might look familiar. It's the marginal rate of technical substitution. So combining these equations, we found that the marginal rate of technical substitution is equal to negative W over R. And you might recall in the very first part of this section, we proved that this is going to be the case graphically We had our isocost line, which had a slope equal to negative W over R. We had an isoquant, and we said the cost minimizing bundle is going to be where the marginal rate of technical substitution is equal to that guy. The slope of the isoquant is the same as the slope of the isocost curve. And we can see that you get the same result when you do sort of this algebraic work. Okay? And why is that the case? Because any firm that's maximizing profit is also going to want to produce in the way that minimizes cost. Okay? If you could produce the same output for less cost, then that means you could get the same sales for cheaper, and so you wouldn't be maximizing profit. Okay? So that's the basic trick. We've done it before, except now we have to solve a system of equations. So let's do an example of that.